topic called time series. Let me write that down. Say again? Oh yeah, well, it could be finance, yeah. Okay. Time series. So this is a lot like what's it called? Line graph. So again, it depends on the time. So we have time on the x-axis. So it's a sequence, like for example x1, x2, etc. that depends on only the time. So it is a lot like a line plot we did earlier. So here we have our time, and it could be something like months or days or years or whatever, but it doesn't matter. So like the first time, second, third, fourth, fifth, and here we have our x. And we get a graph like this. So as you were saying, Malik, is it like finance, isn't it? This could be like price of gold or something like that. But we're going to look at this now in more detail. We're going to look at two types of time series. So the first type is for this class. The next type we'll do next time. We'll have a look at something called an additive model. Wow, this is going slow. There we go. Okay, can I scroll down? Yeah. So, in our additive model, what we say is the value, it depends on two parts. A trend part, or well, I suppose if you want a constant plus a trend part plus a seasonal part. Do you know what the word trend means? Trend? Maybe this is something you did in business or economics. What does trend mean? Yeah, how to explain it? Do you know trend? So like this we would say is upward trend. This would be downward trend. And what about seasonal? What does that mean? Maybe this is a word you did in business as well. Seasonal? No?
Reaching a period of time.
Yeah. How would it mean for the shape of the graph, do you think?
Up or down?
Up and down, yeah. So seasonal would mean a graph that goes maybe up in the summer, down in the winter. You know, it'll have a shape like this to it. This is a seasonal. And then a constant, of course, is just a constant like that. So what we're saying is in the additive model, your data might look a bit like this. So can you see that this graph has three parts? There's a constant, so it always starts at least this much. So this is like the constant. there's a trend. This is the trend. And then in green, there's a seasonal part. So down, up, down, up, down, up, down, up, down, up, like this. Can you see that, Jeff? So which do you think is the one we care about? The red, constant, the blue, trend, or the green, seasonal part? Which, the trend is what we really care about. It's the blue one. So we'll look at how to calculate this blue one now. Can I scroll down? Yeah. So this is a word you might remember from trigonometry, period. It means how long for one cycle. So for example, if you look here, one period would be from here here to here. That's one season, one cycle. So when you look at this graph, the way to calculate the period, you start at any point, it doesn't matter. So, you could start here, and you start counting until you get back to the start. So we have 1, 2, and the next one is back at the start. We're back in the same spot. So this one, its period is 2 times. And I don't know what the time is. Like, for example, here, if these were days, first day, second day, third day, fourth day, fifth day, then the time would be 2 days. If it was years, then the time would be 2 years. So it's 2 units of time. So that would be, in this example, 2. So it's, what you should do is count the number of dots from start to end of a cycle. But don't count this one, because then you're counting it twice. You already have it. Let me draw another one for you. You can tell me. Right, so what's the period here? It's 6, yeah. 1, 2, 3, 4, 5, 6. But don't count this one, because we're back at the start. Oh, Junwei, come on. What happened to you?
The bus did.
Okay. The bus didn't come, huh? What bus did you get? What bus did you get? 122. There was a 122 at 8:20. There's one at about 8:30, 8:35. You must have got the one at about 8:50. No, which one did you get?
40.
Did you really? Okay, 8:40. Bad luck for you, so. Okay, so this one here, the time will be 7 units. 1, 2, 3, 4, 5, sorry, 6 units. Okay, can I scroll down? Yeah. Right, so the way to help us find the trend we use something called a move-in average. So I'll give you an example with some data. So let's say we have, 10, 21, 29, 40, 51, 59, and something like 60. Or whatever, something like this. Maybe, have I got that right? Let's see. That's plus 11, plus 8, yeah? Plus 11, plus 8. Let me do that again. Pick these again. Right. Plus 11, plus 9, plus 11, plus 9, plus 11, plus 9. Is that, yeah? Plus 11, plus 9, plus 11, plus, yeah, okay. So the moving average, has anybody heard of this before? Moving average? No? New word, yeah? Well, you all know what average is. So, moving average. What you do is, you take the average of, for example, 2 points, and write the answer down, and then move, and then take the average of the next 2 points, and write it down, and then move again, and take the average again. So, for example, here, the average of 10 and 21, this would be 31 over 2. And then you move again, average of 21 and 31, 21 and 30, that would be 51 over 2. And then the next one would be 30 and 41, so that's 71 over 2, etc. So these are called the moving averages. Do you always use 2 points? No. You choose how many points to use. So you can use any number of points. Is this not right? Mm-hmm. I just think it's a little stuck, and I'm picturing it just going. No. Anyways, that's okay, because I wanted to open up Excel next. So, how many points do you think we should use? So, in this example, I used 2, but how many do you think you should use? Ah, here we go. Yeah, that's it. There we go. Yeah. All right. How many points do you think we should use, though?
The number of periods.
Yeah. Well, it's the number, the period. Yeah. So, for example, in this one, what was our last one? Here was 6. So you should use 6 points for the moving average. So I want to show you an example of how this works. Let's just open up Excel. Okay, we're loading. Now I think Malik, you were saying, but you can imagine these graphs to be like sales graphs, you know. So for example, something like a toy shop. Maybe the toy shop sales increases, but which part of the year would be the busiest part of the year for a toy shop? Christmas, yeah. And maybe the summer as well, you know. So the graph for a toy shop, it would go up in Christmas, and then maybe down in autumn, then up in spring, summer. You know, so it would have this shape as well as it goes up. Okay. So we'll do, I don't know, maybe we'll do a toy shop. Time and then sales. And the sales can be in thousands of euros. So our time will go for months, or maybe quarters. You know what I mean when I say the first quarter of the year? What months are those?
January.
January, February, March, yeah. I'll say second quarter, third quarter, fourth quarter. We'll do 12. So if you can start writing this table down, I'll go up 12 quarters. You don't need to write this one down. This is just to help me with my formula. So I just want you to write these two down. Okay. Now don't worry about the formula. Let's make that pretty. Okay. Great. Alright, so our toy shop in the first quarter sells 150,000, 240, 315, and then 383. So can you see that the best quarter for it was quarter 4? Then if we go to the next year, again the best quarter was quarter 4, and so on. And this toy shop is getting bigger, it's growing. Maybe it's in a new town, lots of children being born or something, I don't know. So the toy shop, its business is increasing. So we'll make a line chart now in a moment. Let me hide this. How many years are here? How many years? 3 years, yeah. Have you got this? Yep. Okay, so let's make the graph now. So you know how to make this graph. It's like a line plot. You have quarters on the x-axis and sales on the y-axis. So if you can try to draw this nicely. It's not as beautiful as I was hoping. Oh well. Quarter and then sales. Sales. Okay. Rats. No, I'll have to start that over. I need the lines to be connected. I picked the wrong graph. Okay, let's try again. Insert, chart, and then we want to have a line. There we go. And this one. X-axis is quarter, and then Y-axis is sales in thousands of euro. Yeah. Okay, I guess that's not too bad. Let me shrink it a bit. I can redo, can't I? Where's redo? Redo. There we go. Okay, now it's back. It's back, but it's ugly.
Redo again.
Can I? It's not giving me the option to redo again.
Oh. Can we do that? Rewrite the numbers again.
I'll just do it again. That'll be the best thing. And this time not make a mistake. Right, insert chart line with the shapes. Quarter sales in thousands, and then time series. Alright, now carefully does it. Okay, just move this over here, and then I'll just pull it down a bit. Okay, great. And then I'll put in the line. And now I know I made this. You can keep the numbers the same if you want, but I'll just change them in my graph to make it a little bit clearer. I think maybe 50 was too small here. That's better. You can see the shape more. You don't have to change the numbers, it's okay. Well, if you want to change it in a minute you can. But I made it bigger so you can see the shape. Right, if you were to look at this, what would you say the period is? What's the...
8.
Would it be 8? We'll have to count very carefully. So we'll start... What would be a good place to start? Maybe here? 1, 2, 3, 4, 5, 6, 7, 7. Because this is back here, isn't it? No. No. To change my numbers, don't I? Sorry. Any better? Yeah. And you know, and also I have this backwards. No, terrible, terrible. Terrible. It's okay. Alright, well this toy shop is doing really badly then because its sales are going down. No, that's terrible. Okay, if you're... Alright, okay. We'll stick with that just to have something. So this toy shop is doing bad. Sales are going down. Right, so anyways, these numbers make it a bit clearer to see. So what's the period here? 4 or 5?
5.
4 or 5? 4, yeah. That's it, yeah. So we start here. 1, 2, 3, 4, and we don't count this one because we're back at the start. What's wrong? It's okay? So here, 1, 2, 3, 4, and not this one. So it's 4. Okay, so let's calculate the moving average. Can we get the moving average here? No, we can't, because we only have 1 point. Can we get it yet? No. Now we can get it. So if we just add together these 4 numbers and divide by 4, we'll get 10. And 100, sorry. And now, for the next moving average, Which four numbers do I add together? Where do I start? 100, 75, 100 and 125. We average those four and we get 100. Isn't it? Can you see that? Yeah? And then for the next one, our average is 125, 100, 75, 100. We get 100. Okay, so this is the moving average. Although it's not great because the moving average, usually it goes down. Let's do another example, but let's do one on the page so that I use real numbers I thought of at 1 a.m. last night, which will be much more reliable, it seems, than at 9:30 in the morning. Right, so can you just take one and pass it along then? Can I close this? Okay. That was ugly, terrible. Let's have a look at a nice one. Right, can you all have a look at the first question? Month and sales. So we go January, February, March, April, May, June, July, August, September, October, November, December. And sales, 100, 350, 300, 250, 500, 750, 700, 650, 900, 1150, 1100 and 1050. Okay, so the first question is plot this. So that will be no problem. Let's make the graph here. Insert, chart, make a nice line graph. Okay, the x axis is month and the y axis is sales, and this is question 1. There we go, that's what I want. Okay, I'll just shrink this a bit so I can fit it in. Okay. Right, so this is our first graph. You don't have to draw it exactly like that, but if you just want to, please just do a kind of rough drawing in your notebook. So this is what question 1 looks like. So that's part A, plot this. Okay. Part B is what is the period. So to help us with that, we should draw in our trend line. Let me add it in. Right, so now that you have this picture, what's the trend here? What's the period? 4. Very good, yeah. So for part B, the answer is 4. Okay. Now let's calculate the moving averages. Can I just move this graph a little bit? I'll just move it out of the way. Let's move this out of the way. Okay. Right, can we have a moving average? Moving. Can we have a moving average here? No. No, but we can here. So we average the first 4 numbers. 250, yeah. And then for the next one, we average the last four numbers, 350, 300, 250, 500. So we get 350. And we continue this all the way down. So each of these is the last four numbers averaged. So like for example, this 750, what four numbers did I use to get the 750? 900, 650, 700, and 750. Okay. Right, so can you write that down so far now?
The first 250 is the...
This 250 is the average of these four, yeah. On the graph, what do you think the moving average is on the graph? Very good, yeah. So these moving averages, actually, they're kind of like the trend line here. If you look at the moving average, how's it changing? What's the change each time? Increasing by 100. So actually that's the trend. This trend line here is increase by 100 every month. So the trend is a 100 increase per month. So that's the answer for part D. If you look there, calculate the trend. The trend is a 100 increase per month. That's the trend. Can you see that in part D? Yeah.
Is it stable increasing last year?
Say again?
Like increasing...
Oh yes, it should be. That's my last example was horrible. There was no trend. It was just continuous 100. But this one here, you can see that it's increasing by 100 each month. Yeah. Okay. Next now. So there's something, well, there's the seasonal part now. So the seasonal part is the difference between the trend and what you actually have. So it's a little bit like what? What did we do that recently that's like this? The difference between the line and the point.
Error?
Yeah, residual. Yeah. So here in April, for example. So, for example, well, I guess this one's not too clear. So the seasonal part, it's the difference between these two. Okay, now, let's see. If I go back here. So can you see in the graph, sometimes the line is actually on the point, and sometimes it's quite a big difference. Sometimes what they ask you to work out in the exam is the average distance here, which is not too difficult. What you need to do first is get the errors, or the residuals. So that would be this minus this, and that's 0 here, 150, and so on. And then we can average those. So this is like the average seasonal difference. Now, if you're wondering, these points here, they don't line up perfectly with the graph here. The problem is you're missing 3 values here at the start. So it means that the two don't line up. But it doesn't really matter for the calculation of this. It's still an average of 133. So the distance on average between the point and the line is usually about 133. So for example, here the distance will be 0. And here the distance is, what's that, like nearly 300? So on average the distance is 133. Okay, can you write that down? So this is called the average seasonal difference. Okay, you got that part written down? Yeah. Now you notice that here the seasonal part actually is repeating. Can you see here it goes 0, 150, 300, 150, 0. 150, 300, 150, 0. So although you don't have the numbers here, you could still actually write in this part here because it's repeating. So what number do you think I would need to put here?
150.
Very good, 150. And the number here? 300, and here? 150, isn't it? Yeah. So can you fill that in? So in fact, although you don't have the numbers here, because this is repeating, you can still get the seasonal part here.
Will be always like this. Will be always like this.
Yeah. Yeah, they usually make the question so that it has a repeating part to it.
Why it has like this kind of explanation? Why it has like this kind of explanation?
Why is it like this?
Yeah.
No idea. This business, I don't know. There's something special about it.
In the normal life situation.
The examples I think of are like tourism or toy sales, anything that kind of depends on the time of the year. So if you have a hotel which is growing, there's an upwards trend, but of course with the trend there's also seasonal parts like summer, winter, you know. So this would be like, I don't know, you did this in business, seasonal business? You know, a business that does a lot of business at one time of the year and then not so much business at another time of the year? No? But you know the idea anyways. So like school, for example, the numbers would be high in September and then high in January but low in the summer. So DIFC, maybe it's increasing each year, but then at different times of the years we have different student numbers. So the graph would be high in September, high in January, low in the summer. High in September, high in January, low in the summer. And it's increasing up. Yeah. Okay. Have we got the seasonal part here? Now, the next part is try to predict what the next value would be. So we kind of have a pattern of what's happening here. Middle, top, middle, bottom. Middle, top, middle, bottom. Middle, top, middle, bottom. So the next value should be the middle. So the next value should be on the line. So if you look here at this next value here, what do you think it might be? Well, we kind of know what the next moving average should be. What's happening each time? This one should be 1150, shouldn't it? Yeah. So in fact, what you could do if you wanted to, is you could call this x, and the average of these four numbers, what should it be?
So, is it 200, 100, 200?
It should be.
200?
It could be, yeah. Let's calculate exactly. So the average of these four numbers should be 1150. Can you try and get the x? So let's see what we got. 1150. Let me scroll down. 1150 plus, what was the next one? What was after 1150? And then next? 105? Like this? Plus x over 4. That should equal 1150. Okay, did anybody get the x? What is it? 1130. Yeah? Yeah? Yeah?
Oh, no. Sorry.
That's okay. That's what I thought. What is it? 1300. Yes. Perfect. Yeah.
Is there any different size like physics?
Yeah, physics could be one. Wait, just listen 1 sec. Wait. So, in the exam... wait. In the exam, they said in the syllabus that they won't... Oh, please, just listen. I'm giving you, information that's important for your future. They said in the syllabus that they won't ask you to calculate this. However, I don't believe them. So, last year and the year before that, and in fact for the last 5 years, they ask you to calculate the seasonal part. But they said that they won't ask you to calculate it this year. So maybe they won't, but I don't believe them, in my opinion. So just in case, I wanted to show you how to calculate the seasonal part, but I think all they'll ask you to do in the exam is calculate the moving average part and draw the graph, which is, I think, pretty easy to do. Yeah? And just one last thing, right, just before you go for freedom. I usually put the moving average at the end of the 4 numbers, but some people, they might feel better about putting the moving average kind of in the middle of the 4 numbers. So, for example, if I had 4 numbers like A, B, C, D, E, F, G, I put the moving average at the end of the 4th number and move across like this. But what some people like to do is they like to put the moving average somewhere in the middle of the 4 numbers and then move across. And some people might even want to put the moving average at the start of the 4 numbers and move across. So I'm just telling you this, if you look at past exams, sometimes they put the moving average in the middle or at the start of the 4 numbers as they move across. But I don't think it really matters. You can just put it at the end of the 4 numbers. I think this is a better place to put it because you need it after the 4 numbers. Yeah. Okay, now you're free.